Hello, very good evening, guys. Welcome to the faculty-driven platform that is Resultant. Very good evening, all of you. How are you all? Okay, so today we are gonna practice the second most important subject for SSC, that is thermodynamics and its application. In application, basically, I've covered power plant, IC engine, and RAC, all the questions from all the three applications. Okay, so very good evening. Please do let me know whether my audio and video all good, all perfect. Yes. Let me check. Okay, all good. Right. So thermodynamics is a very important subject for SSC. I like, if you have seen my previous sessions where I've taken up like the subject wide analysis for SSC for mechanical students, there you have a clear idea that if you want to score more than 60 or 70% of the question from the technical part, you have to cover fluid mechanics and thermodynamics and its application, right? That basically covers 60 to 70% of the entire syllabus. Okay, so let's begin the practice session, and I hope everything is good with audio and video, right? Okay, chaliye. So I hope everyone has connected with us on Resultant, because on this platform you will be getting a one-stop solution for all the preparation for all the competitive examination, that could be for E or JE or even GATE or ESE. Okay, and you can do connect with me on my Telegram channel also, but before that, please do like this session and do subscribe to this channel if you are a serious candidate for and willing to crack the GATE examination. Okay, and do share this video so that we can start off this session, right? Okay, chaliye. So this is my Telegram channel where you can do join with me, that is Mechanical by Suraj Gopi, and this is my mail ID, that is suraj@resultant.in. Okay, so shall we begin? Yes. All right. So let's go with the first question on the screen from and these are all the most important 30 PYQs for your SSC. So first question is on the screen. Which of the following are the intensive properties? Kinetic energy, specific enthalpy, entropy, and pressure. A, B, C, or D? Let's see. Which of the following is the combination of, or which are the following are the intensive properties? Quickly, let's try to see what is your answer to this question. Chaliye. Is it option A, option B, option C, or option D? Kinetic energy, specific enthalpy, pressure, or entropy? Obviously, if you try to visualize, kinetic energy and entropy are not the intensive. Specific enthalpy and pressure are the intensive properties. So definitely we can go with option B, that is 2 and 3 only, or only 2 and 3. Option B is the correct answer. Okay, chalo, next question. Dash is not a property of a system. Specific volume, pressure, heat, or temperature? Easy question. Dash is not the property of the system. A, B, C, or D? Specific volume, pressure, heat, or temperature? Obviously, if you try to visualize specific volume, pressure, and temperature, these are the properties of the system. Only heat is not the property of the system. Option C is the correct answer. Okay, done. Next, very important, this is an interesting one. For the given process 1, 2, 3, 4, 1, consisting of 2 isentropic process and 2 isochoric process for a PV curve, which of the following is the correct representation of TS scale? Which of the following is the correct representation of TS scale? Now, there are 4 options on the screen. Try to visualize which of the following is giving us a correct representation of the TS scale. Have a look for PV curve, right? And after seeing the PV curve, you will be able to get the correct answer: A, B, C, or D. And let me write the question number also. 1, 2. This is question number 3. Okay, chaliye. A, B, C, or D? Now, if I try to visualize, if you see the direction of the arrows is 1, 2, 3, 4, it is going from 1 to 4 and 4 to 3. This is not possible. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So among B, C, and D. Now, if you try to see A 1, 2, 1, 2 is a isochoric process, right? So, and this is a TS curve. 1, 2 should be isochoric. So 1, 2, 1, 2. This is not possible. This is right. So between B and C, what is the correct answer? Between B and C, what's the correct answer? Now you know that as the pressure is increasing, definitely the temperature is gonna rise. So at 2 the temperature will be higher than as compared to that of 3. Fine. Quickly, A, B, C, or D. And definitely this is not. This is a simple example of a Otto cycle. This is an example of a Otto cycle, and if you try to get the TS curve for Otto cycle, without any doubt, you will be getting option B as a correct answer. Option B as a correct answer. Okay, fine. Because if you try to visualize, we are having isentropic process. Isentropic, so entropy, constant entropy, that should be a vertical line. That should be a vertical line. So obviously we will be getting option B, right? And here if you can simply see, we are having this as a 2, 3 and 1, 4. 2, 3 and 1, 4. Okay, 2, 3 and 1, 4 are the isentropic, and that 2 is having a higher temperature. Okay, clear? So option B is the correct answer. Done? Clear hai? Chalo, next. During throttling, which thermodynamic process, property does not change? A very easy question. During throttling, what is the meaning of throttling process? What is the meaning of the throttling process? Question number 4. A, B, C, or D? Throttling process means there's an isenthalpic process. Isenthalpic process, right? And constant enthalpy, that means option B is the correct answer. Throttling is nothing but isenthalpic process, that is option B is the correct answer. Clear? Next question, number 5th on the screen. A piston of 0.1 diameter expands over a stroke of 0.2 meter under a constant gas pressure. The work done by the piston is, work done quickly. They are giving you the diameter, they are giving you the stroke length, they are giving you the pressure. Okay, that is 2 into 10 to the power 5 Newton per meter square. We are asking you what is the work done. Work done is nothing but, what is work done? P del V, change in volume. Volume is area into the stroke length, right? The volume is equal to area into stroke length. Chaliye quickly. So area is pi by 4 into 0.1 square into stroke length is 0.2. Place it over here. Pressure is given and tell me the final correct answer. So work done will be equal to 2 into 10 to the power 5 into pi by 4 into 0.1 square into 0.2. Solve it and tell me the final correct. Is it A, B, C, or D? Is it A, B, C, or D? So this get cancelled. This is 2. This is 0.1. So it will be something around pi into 2. That is 314 joule. Approximately 314. Option A is the correct answer. Okay, 3.14 into 10 to the power 2. So we are getting option A as the correct answer. Chaliye, next question. An insulated box containing 0.5 kg of gas having CV value as 0.98 kilojoule per kg Kelvin fails from, not fails, very good, falls from a balloon 4 kilometer above the Earth's surface. The temperature rise of the gas when the box reaches the ground or hits the ground. Chaliye, A, B, C, or D? A, B, C, or D? This is question number, I think, 6th. Okay. Chaliye, quickly. A very easy question, बहुत easy question. देखो, obviously what we can do is, एक insulated box है, right? It is falling from 4 kilometer above the Earth's surface, and when it hits the ground, that rise in temperature will be. So obviously the potential energy will be converting into your heat energy. We can say mgh is equal to m into cp into delta t. M get cancelled out. This is 9.8, height is 4000, Cp value is 980 because this is kilojoule na, into delta T. So delta T कितना आ रहा है? That will be 9.8 into 4000 divided by 980. That will be equal to, I think, 40 Kelvin. Option C is the correct, because this is a temperature difference. अगर आप इसको आप डिग्री सेल्सियस पे लिखते हैं तब भी सही है, because that is a temperature difference. Option C is the correct answer. Okay, perfect. चलिए आगे बढ़े. Next question, question number 7 on the screen. Very easy. For a thermodynamic cycle to be irreversible cycle के लिए which of the following condition is necessary? Which of the following condition is necessary? Okay, this is a cyclic integral. A, B, C और D. देखो, this is for reversible. ये तो आपको पता है, this is for reversible. ठीक है. Less than equal to is for, guess quickly. Less than equal to, definitely that is for irreversible. ये आपका irreversible के लिए है. And option C, del Q by T, this is for impossible cycle. Impossible cycle. Okay. अगर कोई भी साइकिल का del Q by T is having cycle integral of del Q by T is greater than 1, that is impossible. That is, that cycle is not at all possible. Option B is the correct answer. Very good, very good. Next, question number 8 on the screen. What is the maximum efficiency of a heat engine operating between 327 degrees Celsius and 27 degrees Celsius? A simple question, diagram बना देते हैं. So we are having a source of 327, that is equal to, we can say 27 to 73, 600 Kelvin, है ना? And we are having a heat engine, and we are having a sink having a temperature of 300 Kelvin. Okay, so there are giving you heat engine. यहाँ से work is being coming out from the system. So they're asking is what is the maximum efficiency? Carnot efficiency की बात कर रहा है. So we can say efficiency will equal to 1 minus, let's say this is T1 and this is T2. So 1 minus T2 by T1. So 1 minus 300 by 600, that is 1 minus 1 by 2, that is 1 by 2. Option B is the correct answer. Option B is the correct answer. Clear hai? Okay, the maximum efficiency of that heat engine is option B. Clear hai? Chalo, this is work out. Okay, next. Heat of 1000 kilojoule is supplied to a heat engine from a reservoir at 1000 Kelvin, and it is rejected to waste heat to a river at 300 Kelvin. The heat engine work output is 400 kilojoule. What is its efficiency? They are asking about efficiency. Maximum की बात नहीं कर रहा. Okay, चलिए. So we know again the source and sink, but अब हम लोग will be writing in terms of the heat also. This is heat engine. We are having the work output, right? This is 1000 Kelvin. This is kitna Kelvin? 300 Kelvin. Okay. Quickly, A, B, C or D. Heat engine from a reservoir at 1000 Kelvin. Acha, Q1 is equal to 1000 kilojoule. Okay, and work output is 400 kilojoule. So what is the efficiency? Efficiency क्या होगा? What is efficiency? Your work output divided by the heat supplied to the heat engine, right? That is Q1. That is 400 by 1000. That is nothing but 0.4 or 40% is the correct answer. Option A. Option A, 40% is the correct answer. Clear hai? Okay, next. If a Carnot cycle operates between the temperature of 1800 Kelvin and 1000 Kelvin, what will be the lowest heat rejection per kilowatt net output of the engine. आपको निकालना है what is the heat rejection per work done, okay, because that is net output, work output. This is you have to calculate, this ratio you have to calculate, मतलब per unit work done, per unit work done. This is I think question number 10th na, 8, 9 and 10th question. Quickly, 10th question, heat rejection per work output, A 0.8, B 1, C 1.25 या D2. Simple है. We know that what is the efficiency? The maximum efficiency is equal to 1 minus the lower temperature upon the higher temperature. That is 1 minus 1000 divided by 1800, right? That is simply we can say 800 by 1800. Okay, fine. And we know that is also equal to the heat supplied to the heat engine, or QS, heat supplied to the heat engine, Q1 divided by work done. Okay, fine. So here we can say Q1 will be equal to, Q1 by work done will be equal to 1800 by 800. Okay, or we can say 18 by 9 by 4. 9 by 4. What is Q2 or Q rejection is equal to Q supplied minus work done. Fine. So try to divide this. So QR divided by W is equal to Q1 by W minus 1. That is 9 by 4 minus 1. That is 5 by 4. That is 1.25 is the final correct answer. 1.25, option C is the correct answer. Perfect. ठीक है, 1.25 is the final correct answer. Clear? चलिए, बहुत बढ़िया. Next question 11th on the screen. Option A, B, C or D. Which of the following statement is true about the engine having an efficiency of 60% working under the temperature limit of 1000 and 540? You have to tell me, if a engine is working between the temperature limits of 1000 and 540 and it is having an efficiency of 60%, is it a diesel or Carnot or an auto or an hypothetical? देखो, whenever you are getting these kind of questions, 99% of the time you will be getting option D, that is hypothetical. कैसे check करते हैं? देखो, not a single engine will be having efficiency more than that of a Carnot. And a Carnot is having the highest possible value between two temperature limits, right? तो एक काम करते हैं, let us try to calculate the efficiency by using the Carnot cycle. T lower by T higher. So 1 minus 540 by 1000. That is nothing but this will be 6 कितना होगा 46 460 by 1000, or we can say 46%. That means between 1000 and 540 Kelvin maximum possible efficiency that we can achieve is only 46%. और यहाँ पे जो inventor है, जो statement बोल रहा है, that is saying 60%, that is completely bogus. It is a hypothetical engine. This is not possible. Option D is the correct answer. ठीक है, clear? Option D, क्योंकि 46% आपका max, this is the Carnot efficiency. This is your Carnot efficiency and we are getting Carnot efficiency 46%, 46%. और यहाँ पे statement they are saying the 60%, which is not possible. So from here we are getting option D. It is an hypothetical engine. Option D is the correct answer. Okay, चलिए, question number 12th on the screen. Very easy. Which of the statement is incorrect? Work is a high grade energy, heat is a low grade energy, low grade energy can be converted into high grade energy in a cycle. None of the above. Quickly. Option A, option B, option C or option D. Which of the following statement is, देखो यहाँ पे work is high grade energy बिल्कुल सही है, heat is a low grade बिल्कुल सही है, low grade energy can be converted into high grade energy in a cycle. This is not correct. दिस इज नॉट करेक्ट. हाई से लो पे जा सकते, लो से हाई के लिए वी हैव टू गिव सम वर्क इनपुट, जिसको हम लोग रेफ्रिजरेशन सिस्टम में यूज करते हैं, है ना. वी आर यूजिंग इन अ रेफ्रिजरेशन सिस्टम. चलिए ऑप्शन सी इज द करेक्ट आंसर. 13th क्वेश्चन ऑन द स्क्रीन. What will be the specific enthalpy of a steam at a pressure of 2 megapascal and Reynolds fraction of 0.9? So X is given as 0.9, where the property of the steam at 2 megapascal are standard liquid, that is HF is equal to 900 kilojoule per kg, and saturated vapor है ना, तो Hg is given as 280 kilojoule per kg. So they are asking about H value. बहुत easy है. H is equal to HF plus X HFG, right? और HF plus X HG minus HF, right? चलिए HF कितना है? So HF is 900 plus X value is 0.9, 2800 minus 9. चलिए सॉल्व कीजिए. प्लस 0.9 इंटू 1900, आई थिंक सो 998, है ना. हाँ ठीक है. सो यू आर गेटिंग समवेयर अराउंड 2610, 2500, 2680 और 2570. So I think you are getting somewhere around 2610 kilojoule per kg. एक बार चेक कीजिए. Are we getting somewhere around this one 2610, 981, 17 plus 9, 26. हाँ correct. This will be somewhere around 900 plus 1710. So we are getting this one. Option A is the correct answer. Option A 2610 kilojoule per kg is the correct answer. चलिए question number 14th on the screen. Which of the following is true for enthalpy of vaporization at critical point? Simple question. What is the enthalpy of vaporization at critical point? Zero, maximum, minimum, zero or constant? Simple question है. TS diagram से समझेंगे. Yes, quickly. So at this point there is no change in enthalpy, and this is the TS diagram. This is a critical point. Okay, so we can say there is no change in enthalpy, so we can say we are having the enthalpy of vaporization is equal to 0 at critical point. Option C is the correct answer. ठीक है, done. Question number 15 on the screen. Which of the following is true for a process 1.5? चलो see the diagram carefully. 1.5 के लिए this is a TS diagram being given. What you can understand from this? देखो process 1.5, it's a vertical line, है ना? It's a vertical line, है ना? So if it is a vertical line, that too on a TS diagram, right? On a TS diagram, so that is an isentropic process. और isentropic process के लिए we know that PV to the power gamma is equal to constant. This is for isothermal, this is isobaric, this is isochoric. Option A is the correct answer. Option A is the correct answer. This is a isentropic process. Chaliye next 16th question on the screen. Oil is flowing in a pipe of 30 centimeter diameter with a velocity of 2 meter per second. Another section of the pipe, the diameter is 20 centimeter. What will be the velocity? Use continuity theorem. Use continuity equation or theorem. A1 V1 is equal to A2 V2, right? So this is pi by 4 D1 square into V1 is equal to pi by 4 D2 square into V2, right? So यहाँ से D1 कितना है 30 square into 2 is equal to 20 square into V2. So V2 will be equal to 9 by 4 into 2, that is 9 by 2, that is 4.5 meter per second. Option C is the correct answer. Okay, option C is the correct answer. Chलिए next question, question number 17. The smallest section of a nozzle is known as a diffuser, converger, convergent part, divergent part or a throat. Smallest section nozzle का क्या बोलते हैं? What do we call the smallest section of the nozzle? Most easiest question. आज के सेशन का this is the most easiest question. Obviously we call that kind of section called as throat. Option D, throat is the correct answer. Okay, done. Can we proceed? Next, question number 18 on the screen. When steam flows over moving blades of an impulse turbine, when the steam is flowing on the surface of the impulse moving blade turbine, then which of the following parameter is correct? Both pressure and velocity decreases, pressure drops but velocity increases, pressure remains constant but velocity decreases, both pressure and velocity remains constant. देखो velocity तो कभी constant होगा नहीं, will be having the energy, kinetic energy drop. Velocity का decrement होता है when the steam is flowing over the impulse of the blade. So we cannot have option B and D. Now we have to go with A and C. Now the most significant feature, or we can say characteristics of an impulse turbine, is when the steam is flowing over the moving blades, the pressure always remains constant but the velocity decreases. Option C is the correct answer. ठीक है, pressure remains constant but आपका velocity decreases, so that is option C going with this. ठीक है, चलिए next question number 19 on the screen. Increasing the compression ratio in an SI engine. Compression ratio increase करने से tell me what will happen. If you increase the compression ratio, the pressure and temperature is going to increase. Pressure increases, that means temperature increases. Temperature increases means your air fuel mixture is gonna burn, or we can say it will be reaching the temperature much earlier. That means that will increase the tendency for knocking to happen. That means the tendency for detonation definitely is gonna increase. Definitely it is gonna increase. Clear hai? Option B, increase, is a correct answer. 19th question. Chaliye, next 20th question on the screen. Now questions from RAC. In the ammonia water vapor absorption system, that means they are talking about NH water VARS cycle. Which is the refrigerant that we are using? देखो आंसर आपके क्वेश्चन में ही है. It is already given in the question. What refrigerant we are using? Ammonia water vapor absorption refrigeration system. So obviously we are using ammonia as a refrigerant and water as an absorbent. है ना? We are using water as an absorbent. Ammonia we are using as a refrigerant. Okay, so option B, NH3 is the correct answer. Okay, next 21st, very easy. The commonly used refrigerant in a domestic refrigerators, जो आपके घर पे फ्रिज है, what kind of refrigerant we are using? CO2, R134A, nitrogen or ammonia? Carbon dioxide, R134A, nitrogen or ammonia, A, B, C or D. Obviously at our domestic refrigerators we are using R134A, the most commonly used refrigerant in our domestic refrigerators. Okay, B is the correct answer. Chale, question number 22nd on the screen. Domestic refrigerator works on air refrigeration cycle, vapor absorption refrigeration system, VCRS, that is vapor compression refrigeration system, or steam jet refrigeration system. Chaliye, A, B, C or D. Very easy question. We know that the domestic refrigerators, because we want to have an efficient cooling, we are using VCRS cycle, that is vapor compression refrigeration system or refrigeration cycle. Done. Option C is the correct answer. Chaliye, question number 24th on the screen, or 23rd, 23rd on the screen. An important question. Chaliye, let's see. A vapor compression refrigeration system with subcooling is shown in the figure along with the refrigeration enthalpy data. The specific heat of the liquid refrigerant is 5 kilojoule per kg Kelvin. What is the coefficient of performance, COP value? What is the COP of this cycle? Chaliye, see the question and tell me. Question is easy, but only thing is you have to have a proper understanding of the concept. तभी आप इस क्वेश्चन को सॉल्व कर पाएंगे. Quickly. A, B, C or D. A, B, C or D. देखो, let us calculate the enthalpy at the fourth point. इस point पे enthalpy निकालें. Okay, so we can calculate H4. H4 will be equal to, यहाँ पर कितना H3 पे 87 ड्रॉप आया है, 87 minus 5 का टेम्परेचर डिफरेंस, एंड दे आर गिविंग द specific heat of this is 5 kilojoule per kg. So this is 5 into 5, that is 25. So this is 25, that is 59, है ना, 59 kilojoule per kg, है ना, 25. अच्छा 87 है ना, वन सेकेंड, 87, तो ये हो जाएगा आपका कितना, 62 kilojoule per kg. H4 you have calculated. Now what is COP? That is refrigerating effect divided by your work input, है ना. What is the compressor work input? Compressor work input. Now what is refrigerating effect? That is nothing but refrigeration happening from H1 minus H4, na? H1 minus H4, H1 minus H4, and this is H2 minus H1. Input is this one. This is input. So let's place all the values. This is 220 minus H4 is 62. H2 is 257 minus 220. Chaliye, quickly. The final correct answer, somewhere around, what's the nearest possible value? 2.9, 5.4, 4.3 or 3.8. The nearest possible value, approximately 2.9 के round आना चाहिए. Please do check. Approximately 2.9 is a COP. Option A is the correct answer. Please check. Are we getting 2.9? 2.9 या 4.7? एक मिनट चेक करते हैं. 1 second, let me check. कितना आ रहा है? A, B, C और D. चलिए कैलकुलेट करते हैं. दिस इज 8, 21, 21 हो गया तो 15, 62 divided by this is 7, 37. हाँ. So approximately what's the value? 2, 3, 4 point something आएगा. देखो 4 point something, 4.2 something. देखो 4.2. हाँ. So option C is the correct answer. 4.3, 4.27 something. देखिए option C 4.3 is the correct answer. ठीक है, done. Option C 4.27 is the correct answer. ठीक है. चलिए next question, 24th on the screen. A very easy question from RAC. An ideal refrigerator maintains a temperature of minus 23 degrees Celsius when it's placed inside a room of 27 degrees Celsius. Heat infiltration into the refrigerator is 0.5 kilojoule per second. What's the power required to pump the heat out? What is the power required to pump the heat out? So let us draw the diagram. So this is a refrigerator. So lower temperature, So we're having 273 minus 23, 05, 250 Kelvin, and here we're having 300. Chaliye. So they're asking you what is the work input. Quickly, 0.1, 0.03, 0.45 or 55 watt. A, B, C or D. COP निकालिए. First of all, calculate the value of COP because temperature limits is given. Once you calculate the COP, you can use the formulation of refrigerating effect divided by the net work input. Chaliye. And they are given some heat also, na? 0.5 kilojoule per second, that is kilowatt. Refrigerator की system के, so let's say this is Q1, that is 0.5 kilowatt heat is being supplied to the refrigerator. A, B, C or D. Quickly, COP निकालिए. First of all, calculate the value of COP using the temperature limits. So lower temperature, that is 250 divided by 300 minus 250, 50, that is 5. COP is equal to 5. So COP is also equal to refrigerating effect divided by the work input. Work input आपको निकालना है ना? So COP is given as 5. Refrigerating effect is given as how much? 0.5 divided by the work input. Yes. नहीं रेफ्रिजरेटर इफेक्ट हो ना 0.5 दे रखा है. बताइए. Q2 minus Q1 है ना. Quickly. देखो. So we can write it over here as heat supplied. This is Q2. So Q2 divided by Q2 minus Q1. So from here, Q1 is 0.5. So 5 is equal to Q2 divided by Q2 minus 0.5. चलिए, solve and tell me what's the value of Q2 you are getting. Once Q2 you have calculated, Q1 आपका simply आ जाएगा. चलिए, quickly. Q2 कितना आएगा? Solve it. ये हो जाएगा आपका 5. 4 Q2 is equal to 0.5 or Q2 will be equal to 0.625 kilowatt. Please check. Q2 0.625 है ना? 0.625. तो work done will be or work input will be equal to Q2 minus Q1. 0.625 minus 0.5, that is 0.125 kilowatt. I think option कौन सा है? Option A is the correct answer. Nearest value option A 0.1. Exact is 0.125 kilowatt. ठीक है. इससे भी question is being regularly asked. देखो, might be they will be using some different value. But आपको पता होना चाहिए what is the process of calculating these kind of questions. Clear है? Done? Everyone? Any doubt you are having, please do let me know. Question number 24 done. चलिए question number 25 पे चलते हैं. Question number 25. Same pattern of question. Might be the values are different. A refrigeration plant operates in a reverse Carnot cycle. The temperature is maintained at minus 10 degrees Celsius. Heat is transferred at a rate of 10 kilowatt. The heat is transferred from the cycle to the atmosphere at a temperature of 28 degrees Celsius. What is the power input required to drive the plant? चलिए quickly. Same pattern of question, बस temperature limit change हो गया. So we are having the upper limit. This is your work input. ठीक है, this is your refrigeration cycle. Quickly, lower temperature is minus 10, that is 263 Kelvin, and 273, that is 298 Kelvin. Quickly, and the heat is transferred at a rate of 10 kilowatt. मतलब source sink से refrigeration में it is supplying at a rate of, you can say, 10 kilowatt. चलिए, same pattern of question, same logic, same approach. Quickly tell me what is the answer. बट दिस इज रिवर्स कार्नोट साइकिल, ठीक है, ये ध्यान रखिएगा क्विकली. So calculate COP first of all. COP will be equal to, we can say, let's say this is T2, this is T1. So we are having, one ले लेते हैं इसको 1 ले लेते, 2 ले लेते हैं, चलो. So that will be equal to T2 upon T1 minus T2, 263 divided by 298 minus 263. Solve it and tell me what is the nearest value of COP. Yes, कितना आएगा? So this will be 263 divided by 5, 35. So this will be somewhere around 7.5. Approximately 7.5 will be the value of COP, and for reverse Carnot cycle, COP will be equal to Q2 divided by work input. So 7.5 is equal to Q2 is 10 work input. So work input will be equal to 0.75 kilowatt. 0.75 kilowatt, option 75. Yes, कुछ वैल्यूज में गलती है क्या? 10 by, अच्छा 10 by 7, 10 by 7.5 होगा ना, 10 divided by 7.5, उल्टा कर दिया. Somewhere around 1 point something, सॉल्व करना पड़ेगा. This is 4 by 3 है ना, that is 1.333 kilowatt. 1.33. So nearest value we can go with option B. ऑप्शन बी है सर, अच्छा नॉट बी, सी दे रहा तो रखा, 1.33 दे रखा है, ऑप्शन सी 1.33 से करेक्ट. क्लियर है? डन. 1.33. बस one thing you have to understand is what cycle they have given you. They have given you a reverse Carnot cycle. Done. चलिए 26 question on the screen. What is a dew point? Easy question. Dew point is क्या है? ऑप्शन ए इज द टेम्परेचर एट विच कंडेंसेशन ऑफ द स्टीम इन सैचुरेटेड एयर विल स्टार्ट. द लोवेस्ट अटेनेबल टेम्परेचर फॉर अ मिक्सचर ऑफ एयर एंड स्टीम dependent on the pressure of air is used in connection with air conditioning. A, B, C or D. Dew point is that temperature at which the condensation of the steam is basically starting. That is option A is the correct answer. Okay, chaliye 27th question on the screen. In vapor absorption refrigeration system, which of the following fluids are commonly used? VARS cycle. In VARS cycle, quickly tell me what kind of fluid is we are using. Are we using air and water? Are we using sulfur dioxide and water? Are we using ammonia and water or freon and water? देखो, if you remember 3-4 questions back we have solved approximately same pattern of question. If you remember, बिल्कुल same pattern of question था. बताइए, in VARS cycle we are using ammonia, water, ammonia as a refrigerant and water as an absorbent. Option C is the correct answer. Clear? Done? चलिए question number 28. On a psychometric chart, the well bulb temperature lines are horizontal, vertical, inclined or sloping downward to the right or curved. बताइए, in a psychometric chart ऐसा दिखता है कुछ? What does this mean? देखो, यहां तो होता है ड्राई बल्ब टेम्परेचर DBT, यहां होता है आपका स्पेसिफिक ह्यूमिडिटी, स्पेसिफिक ह्यूमिडिटी. ठीक है, तो ए और बी तो नहीं हो सकता. चलिए क्विकली, वी नो दैट wet bulb temperatures are the inclined line sloping towards right. These are WBT lines. वेट बल्ब टेम्परेचर लाइंस. एंथैल्पी लाइन थोड़ा सा और उसका स्टीप होता है ना. द इंक्लिनेशन इज स्लाइटली मोर स्टीपर. दिस इज रिलेटिव ह्यूमिडिटी. दिस वन द इंक्लाइन कर्व इज रिलेटिव ह्यूमिडिटी. ओके चलिए 29 second last question on the screen. The condenser and the evaporator tubes in a Freon refrigeration plant are made of steel, copper, brass or aluminium. Quickly. In a Freon refrigeration plant, the condenser and evaporator tubes are basically made up of steel, copper, brass और aluminium. देखो हमें पता है Freon का एक property है. Freon is actually reactive free from copper, so that is the reason we are using copper tubes in condenser and evaporator in our Freon refrigeration system. Okay, because Freon does not have any corrosion effect on copper, and that is the reason we are using Freon in Freon refrigeration system copper tubes for condenser and evaporator में. Clear है? Fine. चलिए last question, again a numerical. A foot compartment of refrigerator is maintained at 4 degrees Celsius by removing heat at a rate of 360 kilojoule per minute. The heat, if the required power input to the refrigerator is 2 kilowatt, what is the COP of the refrigerator? चलिए quickly last question है. What is the COP of the refrigerator? देखो obviously we are talking about refrigerator, so because for that we can say the heat removed divided by the work input. यही था. कितना है 360 divided by 60 because it's given in per minute, right, divided by 2, so that will be equal to 6 divided by 2, that is 3 is the final correct answer. Option D is the correct answer. The COP of this refrigeration system is option D, 3 is the correct answer. Okay, so these were the 30 most repeated PYQs that I wanted you guys to practice on this session live with me. And the student, those who are seeing in the recorded session, make sure you are practicing from question 1 to 30th all in one go. Do not skip any question because each and every question is going to give you some additional information for your examination. Okay, fine. So that's it from my side. I hope you all enjoyed this session. Make sure everyone is joining our faculty level platform, that is Resultant, because it is a one-stop solution for all your competitive examinations. Okay, and before leaving the session, please do like the session and subscribe to this channel. Thank you guys. Bye bye. Take care. Stay safe and enjoy your day with Resultant. Thank you.